Good morning, everybody. Happy Friday. I think this is the first time we've ever put a lesson out on the Friday instead of an assignment. So save that till the very end of the year. And in this one, we're jumping into some word problems. So we have our methods of solving systems. Now's when we put some context to them and we solve some problems. So I'm actually breaking this up into 2 days. So you'll do one today, one Monday, and then we kick off our review Tuesday, and our final assignment will be Wednesday. So we are really rolling through it. Okay, so with that said, let's jump in and solve a few word problems for today. Alrighty, page 641, and we're going to look at solving some systems where there's a context to it, where there's a word problem. And some of these are actually going to look really familiar to some of the stuff you did in grade 9, but we're way better equipped to handle them now. And I think we're going to be ready to rock and roll. So just as a reminder, there are 3 methods for solving a system. Graphically, okay, using substitution and using elimination, okay? So if I don't tell you, you can use all 3, okay? If I say you have to use graphically, or you have to use substitution, or you have to use elimination, obviously you have to use that one. Sometimes I'll just say, hey, solve it algebraically, okay? And that would be these 2, the substitution and elimination, the ones that I actually do by hand. So keeping in mind there's 3 methods. Sometimes it's easier to use one method or the other, and sometimes I'll tell you which one to use, okay? We are going to use those methods for problem solving, and here's kind of the step-by-step thing. And I'll go through this quickly, but then we'll actually do it. Okay, step 1, introduce the variables. Okay, I need to, talk about x's and y's or something like that. Form a system, so write the equations down. Solve it, okay, and then answer the problem and check your solution, okay? So if you think back at the very start of this unit, we talked about the burgers, where there were like 3 different burger restaurants, and we set up the price of burgers and the cost of the meal and all of that, and the salads. Well, that was this process. We just didn't really formalize it. Okay. First one, numbers application. The difference between 2 numbers is 9. Okay. The larger number is 3 more than twice the smaller number. Find the numbers. Well, the first thing I'm going to do, if I'm going to solve a system, if I'm going to talk about this mathematically, I need some variables. Okay, so we have what's called a let statement. And you say let, and then I need to pick a variable. And because I'm not very creative, because I'm not unoriginal at all, I usually pick x for my first variable. And if I need a second one, I pick y. Okay, so then I think, well, what is x going to represent? What is the context here? It's just numbers. It's kind of like a riddle. It's kind of like a puzzle. It's asking you to find 2 numbers that meet this criteria. Well, it says there are 2 numbers. There's a larger one and a smaller one. So I'm going to say, well, let x be the smaller number. Okay. And then the way a let statement works, and you can just do the number sign if you want, is here's my first let statement. And then my next one, I just go below. I don't need to write let again, but I say let y be the larger number. If one of them is the smaller, the other one has to be the larger. Okay, so now instead of saying smaller and larger, I say x and y. All right, next step, so that's stating our variables. The next step is to actually come up with an equation. Okay, well, the very first sentence is actually an equation. The difference between the 2 numbers is 9. Difference meaning subtraction. Okay, so if I subtract these numbers, I get an answer of 9. So I'm going to write equation 1. The difference is equal to 9. So it's either x minus y or y minus x, right? That would be difference. Well, figuring out which it is, this is a positive answer. So it must have been a big number, take away a small number. The larger take away the smaller. That's how I end up with a positive answer. Y subtract x equals 9. That's my first equation. Okay. If I'm going to solve a system of equations, I probably need to have two equations. So then you go to the other one, which says the larger number is, and is that key word where it normally means equals. The larger number is, so I'm thinking y equals 3 more than twice the smaller number. Okay, let's just write that out. The larger number is y equals. Y is the larger number. It is, or it equals 3 more than twice the smaller. Well, 3 more, that would be like adding 3. Twice the smaller number, that'd be like 2 times the smaller number x. And then 3 more than that, so plus 3. Okay, fantastic. I have my two equations. Now I can solve this system. Okay, so whenever I have something, I need to make sure I have my two equations, and then I solve. Well, I'm going to say, let's solve this algebraically. So could I solve this with my graphing calculator? Absolutely. Okay, make them both y equals, plug them both in, find the point of intersection. I don't want to do that. So I look, do I do substitution or do I do elimination? And it's my choice. I think it's really easy to do substitution because one of them, equation number 2, is already isolated for y. I've already isolated the variable. So I can say, let's take equation 2 and let's plug it in. Let's substitute it into equation 1. So equation 1 is y minus x equals 9, but I know y is just 2x plus 3. 2x plus 3, take away the x, equals 9. Okay, those brackets were actually unnecessary in this example because all I'm doing is subtracting the x. I'm not multiplying or dividing, but I always plug in with brackets. X plus 3 equals 9, and I would subtract 3 from both sides. There you go. X equals 6. Okay, found one of my numbers. Okay, found one of my numbers. Finding the other one, I'll just move my work up here. I can go back into either of the equations. I could go plug it into here and solve for y, or I could plug it into here and solve for y. I'm going to pick this one, right? Y equals 2x plus 3 because it's already solved for y. I don't have to do any algebra. I just go right ahead and solve. 12 plus 3. Okay, y equals 15. Okay. Well, I solved my answer. X, that's the smaller number, it's 6. Y, that's the bigger number, it's 15. Hey, I think I'm good. Okay. It says to verify, right? It said we should verify our answer. I'm not going to verify just to save time. We can absolutely always verify our answers. Take the x and y, plug it into this equation. Take the x and y, plug it into that equation. It has to satisfy both. What I'm going to look at just quickly informally is the difference between the two numbers is 9. 15 minus 6 is 9. Oh yeah, that works, right? And the larger number is 3 more than twice the smaller. Twice the smaller is 12 plus 3, 15. Oh yeah. Okay, so both the criteria work. The only thing I'm going to do is for a word problem, I put a word answer. Okay, the numbers are 6 and 15. And it's not a massive answer. Short, concise, don't write me a paragraph. You just write something like that. The numbers are 6 and 15. Okay, so that's a generic problem. And maybe I give that context. Maybe instead of saying those were numbers, maybe we say they're ages, or it's, an amount of money or something like that. That's just a generic number problem. Okay. Next one. The perimeter of a rectangle is 40 meters. The width is 4 meters less than the length. Find the dimensions of the rectangle. So I'm going to make a let statement. Okay. I'm absolutely going to make a let statement. But I'm also going to draw a picture. Okay. Where I talk about length and width. Okay. The length and width. And that is my let statement. The picture probably tells me enough. I know what my variables mean, but I'll make the let statement anyways. Let L be the length, which is pretty obvious. W be the width. So maybe I could have picked X's and Y's, but I think it's easier to just pick L's and W's. When there's little context, sometimes I pick specific letters. Okay, have my let statement. I've got this nice little picture. All right, and now I'm going to try to figure out, how could I find two equations? So the first piece of information, the perimeter of a rectangle is 40 meters. Okay, maybe I put that on my picture, P equals 40. And then you say, okay, perimeter is like L plus W plus L plus W. Or 2 L's plus 2 W's. Equation 1, 2 L's plus 2 W's equals 40. That's my perimeter. The distance around this rectangle has to equal 40. Okay, they gave me information about the rectangle. Other times, maybe they'd say the area is equal to 40, and you'd say, well, then length times width equals 40. So it's what information did they give me? Okay, equation number 2. The width is 4 meters less than the length. Width is W equals 4 less than the length. Take the length and subtract 4. Find the dimensions of the rectangle. All right, we're going to do that. Okay, I have two equations. 2L plus 2W equals 40, W equals L minus 4. Could I solve this graphically? Absolutely, right? Maybe I rearrange them both for W. I'm not going to do that. Let's solve it algebraically. And just like the last one, it's actually set up perfectly, okay, for substitution, for putting equation 2 into equation 1, because W can be substituted with L minus 4, okay? So take equation 1, 2L plus 2W equals 40, and I'm replacing the W with an L minus 4, okay? And here's where, hey, those brackets were really important, okay? Because I have to do the distributive property. 2L plus 2L minus 8 equals 40. And now I'm solving, and I'll eventually find L. Okay. 4L minus 8 is 40. Start doing the algebra. Move the 8 over. 4L equals 48. And I have my answer. Divide by 4, divide by 4. L equals 12. Okay. Great. Well, that's one of the pieces. Okay, that's one of the pieces. The next thing to do is, hey, can I find W? Can I find width? So I could plug into either of the equations to find the other piece. Obviously, I'm going to pick 2 because it's already solved for W. 12 take away 4, which is 8. Awesome. Okay. Well, there you have it. Okay, that is my answer, right? I've got this side is 12, this side's 8, this side's 12, this side's 8. Okay. Again, verify, right? Verifying is something I'll maybe ask you to do, but really it's something you do on your own. But I can also kind of check this. It said the perimeter was supposed to be 40. Well, okay, 12 plus 8 is 20. Plus 12 is 32. Plus 8, 40. Yeah, this does have a perimeter of 40. And then it says the width is supposed to be 4 less than the length. Yeah, it is. 12 minus 4 is 8. All right, so I checked the context. It's not an official verify, but it is nice to check the context. Okay, word problem needs a word sentence or a word answer. The length is 12 meters. Put my units in my final answer. And the width is 8 meters. Units in the final answer. All right, there you go. So again, doesn't need to be a paragraph, but I do need a sentence for my answer. All right, which we did very similar questions to that in grade 9. I think it's a lot easier now, right? You have different skills that allow you to solve it a lot easier. All right, one more. I think we're going to do one more. Okay. Money applications. So definitely would have looked at something similar to this in grade 9. I think we're going to have an easier time now. Okay. So here we go. Gary had a total of $260 in $5 bills and $10 bills. If he has 33 bills in total, how many of each denomination does he have? So he doesn't have $20 bills. He doesn't have 50s. He doesn't have, loonies, toonies. He has $5 bills and $10 bills. Those are the only two types. So my let statement is going to be defining those. And I am super original, so I'm going to pick X and Y. And what I'm going to say is X, oh no, where am I? There we go. X, let X be the number of $5 bills. Okay. So it's how many does he have? One $5 bill, $2 bill, three $5 bills, whatever. Okay. And then Y would be the same thing, but for the $10 bill, the amount, the number of $10 bills. Okay. So maybe he has 7 $10 bills, right? Which would be $70. Okay. Or he has, 12 $10 bills, which would be $120. Okay. Well, let's come up with some equations. Equation 1 and equation 2. He has a total of $260 in $5 bills and $10 bills. Okay, so it's probably something to do with money on that total amount of money. If he has 33 bills in total, how many of each does he has? That's the easiest one for me. 33 bills, that means, well, however many X's, however many Y's, or however many 5s, however many 10s, needs to add up to 33. So if he had 32 $5 bills, he could only have one $10 bill. If he had 35 bills, he could only have three $10 bills, right? It's the amount of bills is fixed. It's just the amount of each of them that we're trying to figure out, okay? The next one is that 260, and what we're looking at is not the amount of bills, but the amount of money. So what I'd say is for $5 bills, each bill gets me $5. So if I had 1, I'd have $5. If I had 3, I'd have 15. If I had 7, I'd have 35, right? So the amount of money from those $5 bills plus the amount of money from those $10 bills, 10 times the amount of $10 bills, has to equal 260. So the first statement was just strictly about the number of bills. Now this is about the money that they represent. $5 for every $5 bill plus $10 for every $10 bill has to equal $260 because that's how much Gary has. Okay. Well, if I'm looking at these equations, I'm not going to solve it graphically. Let's force ourselves to solve it algebraically. I think the easiest way to do this is elimination. Okay. I'm going to rewrite this one so that it stacks up. It is perfectly stacked up for elimination. X's, Y's, and your constant on the other side of the equal sign. Well, now I just figure out how can I eliminate one of the variables. And what I'm going to say is I bet I could turn an X into a negative 5X so that I have the same coefficient but opposite sign. And I would do that if I multiply everything. I have to multiply left and right on that equation by negative 5. Okay. So what that takes me to is negative 5x minus 5y equals negative 33 times 5, 165. Okay. And I'm not changing the second equation. That one stays the same. Okay. Look at what I've got now. It's ready for elimination. Negative 5x plus 5x gone. Negative 5y plus 10y is just 5y equals 260 minus 165, 95. Divide by 5 divided by 5. And you get an answer of y is equal to 19. Hey, I did it. Okay. I solved for y. So I know you have 19 $10 bills. Okay, 19 $10 bills. As for the amount of $5 bills, well, that's something I'll have to find. So I take the value of y I just found, and I'm going to go back to either of these equations. I just don't know which one yet. Well, I think it's a lot easier to pick 1 because the numbers are way smaller. Okay, so x plus 19 equals 33. Or what I'm doing is I'm taking away those 19 bills, and I'm saying, well, you only have 33 bills in total. Take away the amount of tens, and you have the amount of fives. So this would be 24. Okay, there you have it. Okay, if I wanted to do a verify, yeah, I do a verify on these. Think about the context here. I need 33 bills total. Yeah. Oh, sorry, this is 14, not 24. My bad. Yeah, 14. That makes a lot more sense. All right. Do I have 33 bills total? Yes. 14 and 19, those add together to 33. Does the amount of money add up to $260? I don't know. Let's check. Okay. I would have 5 times your 14. That's the amount of money from $5 bills. Okay. 10 times 19. That's the amount of money from the $10 bills. And if I add those together, I get $260. Yes, I do have $260. Okay. So it checks out with the context. Gary has 14 $5 bills, and 19 $10 bills. There you go. Word problem needs a word answer. Awesome. There you go. So that's kind of 3 contexts we looked at. Strictly a number problem, great. Perimeter or area, I could definitely give you something to do with perimeter or area, or like a rectangle or something like that. And then money. Okay, looking at cash, that's definitely something to look at. So with these questions, right, on a multiple choice question, maybe I'll ask you to go through a whole context like this. Or a lot of times what I ask is just, hey, set up the equation for me. What 2 equations could solve this system? Okay, or, what would this variable represent or something like that? This would typically be a bigger written question, right? That's it for this one. So page 643, 1, 2, and 3. And then we're going to do the second half of word problems on Monday. There you have it. Word problems part 1 is in the books, looking at a few different scenarios. And now you got a little bit of homework, just your 3 questions of homework, no check for understanding, nothing like that. But as always, send your questions into the form, set up a one-on-one appointment, and smash the like button, hit subscribe. Tune in again Monday.